Hello, Flat Earth researchers, debaters and debunkers. Perspective is the imaginary curve of a globe Earth. Perspective's also angular size. It's the same thing. The problem we have with believing we are on a globe is when we take the first person's perspective of someone looking across a flat surface on the Earth and then translating it into this kind of scenario, a side-on view or an external frame of reference. And of course we're taught that we are smart to be able to imagine ourselves on a spherical Earth. And we are told to imagine that down is in all directions around the surface of the Earth towards the center of this alleged globe Earth. We can all perceive that and we can believe it, but it's never been proven. And the simple fact of the matter is that the perspective we have on the surface of the Earth, where everything rises to eye level because of perspective and because of angular size, the only way we can justify this happening on a globe Earth with this side-on view is to have the observer looking down. We are told that we look down to the horizon, and that's why there's always such an argument about the higher you go, the further you look down, and people end up arguing about refraction, diffraction, and differences of fractions of degrees in some alleged drop of the horizon. But the fact remains that the surface and the sky always appear to meet in the middle of our field of view because of perspective. And sometimes we're told that, you know, we're looking into a bulge. So there's no official way to do this. We're told that we're either looking down or we're looking into a bulge, like this guy here. But that can't be true if you're going to have a plumb line that goes directly down, wherever down happens to be on this globe, and then you look straight ahead. Yeah? The surface and the line of sight are never ever going to meet, even and especially if the surface is curving down and away from you. And if you are to perceive that you're on a sphere, then you will always be on top, because there is no up and down in space, right? So there is no looking down to the horizon. So this is just complete rubbish. It ignores perspective, and that's why I say perspective is the imaginary curve. So what's happening? Here we got someone looking at a house that's close by, and whatever is in that person's direct line of sight will remain in their direct line of sight as that object appears to get smaller in the distance. But of course, a small tilt up or down would have that person looking at the top or the bottom or well below or well above that much, much smaller house in the distance. But essentially we know that the laws of perspective dictate that anything above the line of sight, which creates the horizon, appears to come down to the eye level, and anything below eye level will appear to rise up to that eye level. Doesn't go any higher, doesn't go any lower. So of course the problem people will have when they're trying to say that something like the sun will never set on a flat Earth is they take this side-on view and they forget to factor in perspective. They forget to factor in angular size when we get this side-on view. Hence the belief that we're on a globe looking into a bulge or looking down a curve. But what's happening? We always are taught to focus on one particular object. We're taught to focus on the house. But look what's happened to the house as we get further away, or the house gets further away from us, or whatever this object might be. If our direct line of sight is in the center, it will remain in the center of that So of course it appears to be floating. But the thing is, everything in front of us, yeah, is changing in angular size. We've got these angles, this cone of perspective going off into the distance. Everything's coming down, everything's appearing to go up to our eye level. So when we want to represent that in a side-on view, we have to do this. But of course no one ever does this. We have to have the surface as well, rising up to eye level. And we have to have whatever's in the sky appearing to converge and angle down. And this, of course, is angular size. The house is changing size. It's appearing to get smaller and smaller in the distance. And so is the surface. So are the clouds. So is the anything else in the sky. People will demand that the sun changes size, but that's a light in the sky. It's not a physical object. It's not the same as a house, and it's much, much larger than anything else we can compare it to. So arguments about the sun are irrelevant. Yeah? It does obey the laws of perspective because it does appear to sink down to the horizon. And when the sun gets to about here on the horizon, when it's far away, well, of course, half of the sun is cut off by the surface rising to our eye level. So when we see the sun set, we just see the top half. The bottom half disappears as it goes off into the distance, and it gets smaller and smaller. So we see the top half get smaller and smaller as it goes off into the distance. We're not going to see much change in the size or the apparent size of the sun as it goes off on this path towards the horizon. So no need for arguments about the sun when we don't even know what the sun is, and it's not necessarily a physical object that should change in angular size. But something like this does. The surface changes in angular size. Yeah? So, and we call it angular size because there are angles here. Of course, what's happening here is because the surface is in the way, really what we have is a triangle of perspective that's starting beneath the surface, but the surface is in the way. So it's the surface that appears to rise up to eye level. If the surface was transparent, it would be different. Yeah? It's really quite simple. Again, this is something that flat earthers realize and get used to that way of thinking when we try to put all the pieces of the globe belief together, all those compartmentalized explanations. They just don't fit together. But when you put everything together, then you understand that perspective or angular size is the imaginary curve. So I'll just try and draw. We've got this guy here with his cone of perspective making a triangle. Yeah, maybe he's a bit too high. Let's make the angle here 66.6 degrees. I will make this angle 66.6 degrees. And then this angle would be 46.8 to make all the angles in the triangle add up to 180 degrees. Yeah? And then you split this down the middle. So if you divide 46.8 degrees by 2, you end up with 23.4. You understand? So this angle here becomes 23.4, and this angle here on the underside becomes 23.4 as well, because it's split down the middle with the line of sight of the observer. Yeah? So basically we've got a missing 23.4 degrees. And we know that when we are told we live on a globe, we are told we have axial tilt with an axis of rotation that is 23.4 degrees off. And this equator is called the celestial equator. Yeah? But really the celestial equator, but that's the horizon that we see at eye level when we're making measurements of the stars. We start at the horizon, which is the celestial equator. Okay, so we are told we live on a spinning globe and that it's tilted, and so north is facing that way towards Polaris, and this difference in the angle between the orbit of the sun and the axial tilt is 23.4 degrees, which just so happens to be the same number of degrees between the surface and the sky, or the line of sight and the sky, when we could create a triangle like that. Yeah? It's really quite simple to understand, but it's very, very difficult to accept. But it's the simple truth that perspective, or angular size, is the imaginary curve. And it's that angle here, the 23.4 degrees, below our eye level, which is taken out and turned into axial tilt to make us believe we're on a ball. Hence the difference in the directions towards Polaris. Yeah. And that's why when people try to draw a flat Earth looking up at Polaris or looking up at the sun, they find the angles don't match up because they don't factor in perspective. But when you factor in perspective, you use these angles, then you'll see that the difference between the angles that we look up at the sun or Polaris or whatever, as we get further away from it, all add up to 23.4 degrees. The magic number. Maybe I'll do some more videos on this later, but hopefully that's good enough food for thought for now. Get you thinking, get the globe head squirming. Yeah. Thank you very much.